We all enjoy using Arduino for our new next project, and it's one of the better platforms for the prototyping and the debugging phase. In this stage, we often face low memory related stability issues. Most of the time, when we get this kind of warning messages, the program compiles, but while running it on the microcontroller, it gets stuck on random stages, and the code doesn't get executed. In this particular case, it never executed anything after the setup section. Today, I'll show you a few beginner's guidelines as well as couple of advanced methods on how to get around this issue. If we look at the most commonly used microcontrollers on the Arduino platform, we will be able to see that they have a lot of flash memory but not enough SRAM. So, it makes sense to utilize most of the flash memory rather than the SRAM. Let's first start with an empty sketch to draw the baseline. In the second stage, just by adding a serial begin line, we have used up a lot of memory space. So, the best option would be to not to use any serial print if not needed. The third option would be to use a fewer amount of print lines. And again it helps if we use short printed messages. The final procedure would be to place the printed messages in the flash memory. Now, let's move on to the data types. Different type of data types occupy different amount of RAM space. So, always try to use the smallest possible data type where you can store the maximum value of your required variable. For example, if you need to use a counter which will count from 0 to 255, try to use the data type byte rather than using integer or double. We can also use the concept of bit field structure. If we apply the concept of bit field and declare the required amount of bits, then we can easily optimize the memory space. We can also optimize the memory consumption by programming the microcontroller at the register level. Also, in some cases, a LED can be used as a debug method rather than using a printf or a LCD display. In a way, the less amount of library that we use, the better. We can also use local variables. They use the same amount of space as a global variable, but the advantage is that the memory location gets released as soon as the operation ends. There are a few qualifier and modifier methods to optimize the memory uses. Constant and progmem qualifiers can also be used to save the variable in the flash memory. But if you still need more memory space, then either you can switch to a different microcontroller or add an external memory chip. It will mostly depend on the size of the device and the BOM cost. If you are also interested to know how we can add an external memory chip to our Arduino project, then let me know in the comment section below. Also, don't forget to share with us your choice of memory optimization process. If you think that you have learned something new and want to show your appreciation, then consider liking and sharing the video. And for future video updates, also consider subscribing to the channel and ringing the notification bell. Hopefully, I'll see you all in the next one.